So the final answer is the 2 is 2, and then the x minus 2, and the x squared plus 2?
Exactly.
Huh?
Yeah.
What happened to the x plus 2?
X plus 2?
Actually, I think I just might have wrote something wrong.
Oh, okay. I mean, okay.
Never mind. Thank you.
Oh, that's okay. You're welcome. It was x squared plus 2. I'm not going too fast for anyone, am I? Yeah, I hope I'm not. Yeah, I know. Okay, so, but if I do go too fast, if you wanted to write something down, don't be afraid to say something, okay? I mean, I know I do have material to cover, but I want to make sure I'm not going too fast, so. Okay. Are there any other questions? Okay. So let's do another one. So here, right, what we have is another polynomial. Now, how do I even know to use factor by grouping? Mostly because there are 4 terms. If there are 4 terms, that's really what you want to try first. I mean, will factor by grouping, is that guaranteed to work? Well, not necessarily, but if there are 4 terms, it's really what you should try first. Okay. All right. Now, for the coefficients and the constant term, well, if you were to list, the factors of 7 and 5 alone, I mean, you could do 28 and 20 as well, but 7 and 5 are small, so let's start with those. For 7, its only factors are 1 and 7. For 5, its only factors are 1 and 5. Its only factors are 1 and 5. 7 and 5 are also, just like 3, are prime numbers. Their only factors are 1 and the number itself. Now, right away, you can see that the only common factor among 7 and 5 is 1. Well, that tells us the only common factor among the coefficients and the constant term, the only common factor among these 4 numbers here can only be 1. Okay, so the greatest common factor then among the coefficients and the constant term is 1. So B is 1. Now, M is 0, right? Because again, there's a non-zero constant term. So the smallest exponent of x here happens to be 0. So we get that. So the GCF is b times x to the m, which really is just 1. Okay. Now again, I like to have addition between the second and third term. I mean, that's just me. If you don't do that, but you factor correctly, I'm not going to take points off. Now, why do I like to have addition between? Well, here, I can make this into addition by changing subtraction to adding the negative. And then, of course, I put parentheses in, like so. You can also see that the second and fourth term have opposite signs. This is subtraction, the other's addition. So we will have to take out a negative number from the second group. Okay, great. Now, why do I like to have addition between the second and third term? Well, look at the bottom lines, right? If I just, without thinking, put parentheses like so, without thinking. Wait a minute, I shouldn't say without thinking, but if I just put parentheses in, well, this is not going to be the same as the original polynomial. It's not the same algebraically. That's what the bottom line here is showing. Right? This here is actually equal to this polynomial. That's not the same thing. No, that's right. Good. I thought I made a mistake, but I didn't. This is actually not the same as the original polynomial. So you don't have to have addition here between the second and third term. But if you don't, you can see you have to be a little bit careful with parentheses. So again, that's just what I like to do. If you did not change the subtraction here into addition, but you used parentheses correctly, then, that's fine. That's fine. But I'm just trying to illustrate here why you have to be careful with parentheses and if you have addition, it's a little bit easier to get it right. So you're less likely to make a mistake. At least I am. So, all right. Are there any questions on this so far? Okay. So from here, this is our polynomial. We must factor each group here separately. So let's do the first one. Right away, you can see the smallest exponent of x is 2. So m is 2, right? We're factoring out the GCF. We have to find it first. What about 28 and 20? Well, if you were to list the factors, which I guess here you kind of have to, right? These are the factors. And you can see that among 28 and 20 only, the greatest common factor is 4. So the greatest common factor among these coefficients is 4. So our B is 4 for this first group. So the GCF first group is 4x squared. So what do? Factor it out, like so. Like so. And when you factor it out, you divide into each term, as you can see. And so from here, 28 over 4, that's 7. X cubed over x squared, well, that's just x. You can subtract the exponents, 3 minus 2. 20x squared over 4x squared, that's 5. That's what we get. So we have 4x squared times 7x minus 5. That's from the first group. Now the second group here, hopefully you can see its GCF is just 1. This GCF of this is just 1. I mean, 7 and 5 we already saw, their only common factor is 1. And there's a non-zero constant term here. So the GCF of this is 1. But remember, you have to factor out a negative because the second and fourth term had opposite signs. So what do? We factor out negative 1. Okay, so again, from the second group here, since the second and fourth term have opposite signs, you do find the GCF of the second group, but you factor out its negative. which in this case is -1. Factor it out. This is what we get. Factor out the -1. Again, we divide by -1. For the first quotient, sap and sum rules, right? You get 7x. 5 over -1 is -5. But now you can see why we factor out a negative. Remember, we want what's from these groups. We want what's in parentheses to be the same. This was from what we factored here, right? You got this. From here, for the second group, right? We're off by a negative sign, so that's why we factor out a negative. Good. Now, almost done. What's left? Factor out 7x minus 5. Right? That's the common thing in parentheses, and that's what we're doing here. We factor that out. Right? Wait, hold on. I'm getting ahead of myself. There we go. Right? So we factor out 7x minus 5. Okay, so we put that in front. We divide. By dividing, I skipped the step, but we divide it into each term, like so. And of course, there'll be some cancellation. For instance, we'll have this cancels with this. This cancels with this. So we have 7x minus 5 times 4x squared plus -1, which is the same as this. Good, good. Now, we can actually go a little further. I mean, the first term, 7x minus 5, you really can't factor anything out there. But 4x squared minus 1 you can, and we're just using this formula. Namely, we rewrote it as 2x squared minus 1 squared. Right? Because 4 is 2 squared, x squared is x squared. And then we just use the formula. So that's what we get here. Okay. Okay, good, good. All right. Are there any questions on this? So if not, I'll do another one.